Okay, we've talked about different types of factoring now, and now we're ready to see the first kind of main application of factoring. Okay, other than to accomplish the task of factoring, we actually have a motivation behind it. We're going to see a lot more in Chapter 7 on our unit on fractional expressions and fractional equations. But now we see kind of our first application of factoring, and that relates to solving polynomial equations. Consider the equation x squared minus 5x plus 6 equals 0. Right, if we tried to solve this equation using the techniques of that we use for linear equations, trying to get the variable by itself, we really quickly discover we got a problem. I have an x squared and a 5x. Right? I have x in two different forms, and I can't put them together because they're not like terms. So factoring is going to give us one way that we can solve this equation. A little later in the course, we will actually see a second way to solve these equations as well. And the key idea is something known as the zero factor property. Now the zero factor property has a really fancy name, sounds kind of very stuffy. Zero factor property. How are you today, sir? I like to give it sometimes a little bit of a funner name. So I abbreviate zero factor property to ZFP, and then I can sound it out. ZFP. The ZFP. And whether you call it zero factor property or ZFP, it says a very basic, easy to understand idea. And that says that if two numbers are being multiplied together and they're equal to 0, then pretty much everybody, then either A equals 0, B equals 0, or they're both equal to 0. So either A is 0, B is 0, or they could turn out that they're both 0. But that's a true fact. I mean, most people probably get that real quickly without a whole lot of thought. But it turns out it's actually a really special property because 0 is unique. If we allow our numbers to be, fractions and decimals, then if you have two numbers multiplying to be anything other than 0, then there's actually an endless supply of possibilities for each of the two numbers. Once you pick one of them, it kind of figures it out for the other one. For example, if you considered 8, once you know that one of them's 2, you know the other one has to be 4. Once you know that one of them's 16, you know the other one has to be 1/2. Right? And there's endless pairs that would multiply to be 8. But if they multiply to be 0, although there's an endless pairs that multiply to be 0, you can always say something about one of them. One of them has to be 0. Now the way we use this is by taking a polynomial like x squared minus 5x plus 6, and we factor it. That one in particular factors is x minus 2, x minus 3. And then we can make use of this zero factor property because those two things are multiplied. We don't know what x is. We're trying to find the values that would make the equation true. But what we do know is that the only way this could be true is if one of those two expressions, either x minus 2 or x minus 3, is 0. And so we can then conclude that for this to be true, either x minus 2 has to be 0 or x minus 3 has to be 0. That gives us some linear equations that we can solve very easily without a whole lot of work to get our solutions for the equation. X equals 2 and x equals 3. Now, just to see that these answers do in fact work, take the answer of 2 and plug it back into our original equation. So if we plug 2 in, we'd have 2 squared minus 5 times 2 plus 6. And then take a moment and work that out. 2 squared is 4. 5 times 2 is 10. 4 minus 10 is negative 6. Plus 6 is in fact 0. And in like manner, if you took 3 and plugged into that equation, you'd have 3 squared is 9. 5 times 3 is 15. 9 minus 15 is negative 6. Negative 6 plus 6 is again 0. So that's just to kind of confirm for you and show you that the answers we get this way do actually work. They are actually the solutions to the equation. It also shows you a way that you can check, this process. So this is the process that we're going to be using to solve polynomial equations. And the key really comes down to factoring. And so we'll see some more examples in the next videos.